In this case, we have a pulley and there's a string, and we have a condition that the mass of the string is 0 and the mass of the pulley be 0. And we have the two masses m1 and m2. Let's suppose that the m1 is greater than the m2. m1 is greater than m2. Then what happens? The m1 will, this portion will be falls down with an acceleration a, and this direction, this string will goes up with an acceleration a. And let me check out deeply into this pulley. What is happening in the case of the string and the pulley in this condition, in these two conditions, that is the mass of the string is 0 and the mass of the pulley be 0. And if you take a small portion in the string, okay, let it be T1 be the force with M2 is pulling it downwards, and T2 be the force with M1 is pulling it in the upward direction. And then we can say that T2 minus T1 will be equal to M into A, where M is the mass of this small element. Let's assume that this element has a mass of M. Okay, we know that the mass of the string is negligible, that's why this m will be negligible, and if the acceleration is not infinity, it is a considerable value, and so this value, this time will be goes to 0. So we can say it as T1 is almost equal to T2. This is a concept. And from this region also we can say that the tension in the downward direction, let be the tension be T dash be same in these portions, and in this portion the T is same. Let me clear it out. In these portions all are T, and these portions are T until this point and this point. And I am saying that the tension in this string, all of the string will be same. But you may ask how? Because here one of the other case will come, that is the normal reaction. There is a normal reaction in this region. So will the tension in these two sides be changed? That is T dash and T are different, or T dash and T are the same? Let me check out that. If you look at this portion, what are the forces here? Since it is taken as a point, so we don't need to consider the normal reaction. There will be a force in this direction. We can say it as F from this side, and there will be a force from this side, and it is same as F. Why? Because we have derived already that the string's mass is negligible. That's why the force in the two directions should be same on the string. Otherwise there will be a negative force, but that is negligible. That's why we taken the F as same. And if we take a small element here, what are the forces acting on here? Yeah, of course there will be tension in the downward direction, and there will be one normal reaction, N. Yes, and here also there will be a normal reaction in this direction, and here also there will be normal reaction in this direction. And until this point, we can see that the force only in the horizontal component. The vertical component of the tension is fully cancelled by the normal reaction. And one more thing is that the normal reaction direction is constant. That is, direction doesn't changing. Its direction is same. If you do the same principle in this direction also, in this string also, the normal reaction direction is same as in the other side of the string. And the normal reaction, if we increase the tension, then the normal reaction would increase. Only the magnitude of the normal reaction increase, not the direction. That's why if we increase the tension, that will increase the horizontal component of the normal reaction. And so for a particular value of the T, there will be a particular value of F. So in this both sides, there is asymmetry. So if for a particular value of the T, there is a particular value of the F. So if you increase more than T dash, then it will be more than F. And if it is lesser than T dash, it will be lesser than F. In this both case. So it will be only comes, if the F will be same, F is equal to F, then the T dash be equal to T. This is a story I am trying to tell you. And one more concept is that if you can see that the normal reaction is fully cancelled out the tension. The normal reactions has two components. One component is the horizontal component, other component is the vertical component. And if you add up all the normal reactions in the tiny portions, Here it is only the F in this direction. So all the upward component of the normal reaction cancels the tensions. So normal reaction, all upward component, normal reaction of all summation will be equal to the tension of the string. This is the idea. Here also the normal reaction, upward components completely cancel the tension. So if a man is holding the pulley, he should exert a force of 2T in the upward direction, because the normal reaction in the upward component of the normal reactions in the both side of the string, the summation will be equal to the force exerted the man in the upward direction. Man who is holding the pulley. By using all this concept, we can see that the M1 has an upward force of T, that is the tension force, and the M2 also have an upward force as T. So in the case of the M1, there will be an mg downward direction, M1g, and in the case of the M2, there will be an M2g in the downward direction. So first, by the equation of the M2, we can write as the M2 is going upward direction. So the T minus M2g will be equal to M2a, and M1g minus T is equal to M1a. These equations we will got when we considering this object, this M1 object. So by solving these two equations, we can get the value of the T and the A. And if we know the value of the T, then we can find how much force did a man need to exert to hold the pulley in that position. In this time, you may ask me one more question. Why does the pulley's mass be equal to 0? What is its use? I will explain you. If you take a small element here, and the M1 is going in the downward direction, that's why it should rotate in this direction, and it has an acceleration, that's why it should have a force should exert on this small mass piece. And where does that force come from? This force is come from the tension. That is the only force existed there. The normal reaction is a reaction force. So in the downward direction, there will be some tension. So here it is T1, here it is T2. The tension will be changed. That's why we take the mass of the pulley be equal to 0.